Apart from using lignocellulose more efficiently and turning it into high-value products, alternative raw materials should also be considered. In collaboration with the UNITE Flagship program, cattails grown on rewetted peatlands were successfully converted into various biomaterials.
So we have made nanocellulose and lignin nanoparticles out of the cattail biomass. We are mainly using the stem for this, and our approach is that we don't want to form any waste, but use as much as possible from the plant and still be able to make high value added materials.
These bio-based nanomaterials can be used for emulsion stabilization, so we have done some emulsion experiments with these materials separately and also combining the lignin and cellulose-based nanomaterial.
Emulsion stabilizers are used in products like cosmetics, where they are typically made from synthetic surfactants. This cattail-derived solution would enable a bio-based alternative. The team at VTT worked on several demonstrations.
What we did was to obtain lignin-containing CNF, or cellulose nanofibrils. We got inspired from the regular extraction of cellulose nanofibrils from kraft birch pulp, and we were able also to tailor the amount of lignin that they had.
In another demonstration made at VTT, all the parts of the plants were utilized to make a biocomposite material.
We produced a container for cosmetics. This was done grinding the full plant, having leaves, stems, all the sections of the plant there. And after that, we compounded with PLA. Then we end up having an extrusion that was pelletized, and with these pellets we used injection molding to have these cups. This was performed in the pilot lines in Tampere. And then another approach that we have was foam forming, that we have also pilot lines in Jyväskylä. We used also the grinded whole plant and also blended with thermoplastic polymer and have these foam sheets that afterwards we thermoform, and we were able to manufacture cases.
But why use cattails? Cattails are an excellent perennial plant that can be used for restoring peatlands. Peat soils store centuries of carbon, but when drained for agriculture, they release vast amounts of CO₂. In Finland alone, peat croplands emit around 10 million tons of CO₂ every year. Preventing these emissions is a daunting problem.
There are management techniques where you can reduce the emissions, and reducing emission means that you should elevate the water table, and then you should have crop species who grow well on those wet peat soils, and cattail is one of those. The kind of plant species which grows on all continents, and there is lots of traditional use for that species.
These actions could have an important impact on climate change mitigation.
And by converting them to cattail production, we can reduce the emission. In best case, it might be a reduction of 35 tons of CO₂ equivalent per hectare per year.
One of the challenges, however, stems from harvesting in wet conditions, which will require specialized machinery.
It depends what you produce from cattail. If you're happy to have a dry material, you can harvest in wintertime, but if you want to have fresh, green material, then you have to invent machinery which harvests that in summertime.
We can make these nanoparticles from dry or fresh biomass. This enables harvesting of the cattail also in wintertime.